going to be covering how to conduct an independent samples t-test. So here are the basic steps we're going to go over: determining whether it's a one or two tail, determining what the null and the alternative hypothesis are, calculating our t-value, determining our t-critical, deciding whether or not to reject or not reject the null hypothesis, and calculating an r-squared, which is an effect size, if we find significance only. Assumptions we used for two independent groups used with a dependent variable that is interval or ratio. So our t obtained is mean 1 minus mean 2 over pooled variance. And so our pooled variance is going to be using for equal n. And so we can see that that is the standard deviation squared, also known as variance for the first group, plus the variance for the second group over n. And we take that square root. Our n is going to be for that individual group. So we will see what that is shortly. Researchers think that pit bulls are friendlier than other breeds. In order to test this, researchers break dogs into two groups of pit bulls and non-pit bulls. Each group has 20 dogs. The friendliness dog scale goes from 1 to 10, which is what we are going to use. 10 being very friendly, 1 being not friendly at all. Step 1. This is a one-tailed because we're using the word friendlier, meaning more friendly. So we expect them to score higher, the pit bulls, on the friendliness scale. So it's going to be in the positive direction. Therefore, we have a null of the average pit bull's friendliness is less than or equal to that of a non-pit bull. And the alternative is going to be a pit bull on average is going to be friendlier than a non-pit bull. So we're going to have to calculate our t obtained. That is step 3. Now, while we are given our two means, we are not explicitly given our pooled variance. So we have to go through and calculate it. Notice we are just given our standard deviations and not the variance. So all we're going to do is we're going to take each s and plug it in to the pooled variance. So we're going to see down here, it's going to be 2.1, because that's what it is for pit bulls, squared, plus 1.7 for non-pit bulls squared. So that's going to equal 4.41 plus 2.89. We're going to add those two values together, which is going to give us 7.3. So our value is going to be 7.3 over 20, which gives us 0.365. And then we take the square root of that value, which gives us 0.604. And that becomes our denominator for our t obtained. So we're going to just now plug in our values. Our mean one, which is pit bulls, is 8.5. And our mean for the non-pits is 7.5. We're going to divide that by 0.604, which is going to end up becoming 1 divided by 0.604. And that gives us 1.66. Next, step 4, we have to determine our critical value. We have an alpha of 0.05. We have a one tail, and we have a degrees of freedom of 38, and that's because degrees of freedom equals sample size for group 1 minus 1 plus sample size for group 2 minus 1, and we know that each group had 20. So it's 20 minus 1 plus 20 minus 1, which is 19 plus 19. So if we go to this table over here, we know we're looking at one tail. So we have 0.05, because that's our alpha. It's just a default. Unless you're specifically told otherwise, this is the standard to be used. We have the one-tailed, and then we go all the way down to where it says 38, but there is no 38, so we're going to round to the closest one. And that's 1.684. And we have a t-crit of 1.684. Now we're going to use that value. And we're going to see if our t obtained, which is 1.66, falls within the critical region, or the rejection region. And it just misses. Our t obtained falls right over here, but our t critical's over here. So we fail to reject the null. The interpretation for this, there is no meaningful difference between dog types in terms of friendliness. Step 6, we're calculating a effect size, even though it wasn't significance, just to demonstrate. So a little bit about this we're going to calculate an R-square. Ranges from 0 to 1. It's a proportion of variance in the dependent variable that is associated with the independent variable. Small one is 0.01, medium is 0.09 roughly, and 0.25 is large. The way we calculate an R-squared is we take a t-squared obtained value. So we just take our t value that we obtained and square it over t squared obtained plus degrees of freedom. So let's just punch those numbers in. We end up with 1.66 squared over 1.66 squared plus 38. 1.66 squared is 2.76 divided by 2.76 over 38 gives us 2.76 divided by 40.76, which gives us 0.067, which is roughly a medium effect. Thank you for your time today, and hope this was helpful.